Hi, my name is Beverly Ma, and I'm going to teach you about radians and degrees, and show you how to convert from radians to degrees and degrees to radians. Degrees can be denoted by the word degrees or the degree sign written after the variable or number it represents. But today, in all of the examples, I'm going to be using the word degrees to make it more clear. Before anything else, we have to know about the unit circle. I'm going to show you a very basic unit circle. And as we know, in a unit circle, it starts on the right side and goes counterclockwise. The first on the right side is 0 radians, or 0 degrees. Going counterclockwise, we have pi over 2 radians, or 90 degrees. Going counterclockwise again, we have pi radians, or 180 degrees. We are going by steps of 90 degrees. So if we go another 90 degrees, we have 3 pi over 2 radians, or 270 degrees. And finally, 2 pi radians, or 360 degrees. We're going to be looking at 2 pi radians, or 360 degrees, because it's going to be equivalent to 1 full rotation of a circle. If 2 pi radians equals a whole rotation of a circle, and 360 degrees is also a whole rotation of a circle, then that would make both of these values equal to each other. And since we have an equation now, we can simplify it by dividing both sides by 2 to get pi radians equals 180 degrees. If we want to solve for radians, we would divide both sides by pi, and then we would get 1 radian equals 180 over pi degrees. Okay, going back to that previous equation, if we want to solve for degrees, we would divide both sides by 180, and then we would get pi over 180 radians equals 1 degree. Notice that both of these are ratios, and that would be very important when solving these, when converting from radians to degrees and degrees to radians. Example 1 has 3 pi over 4 radians. So that would mean we have to convert from radians to degrees. And we would do that by multiplying by degrees over radians, because the radians would cancel out. Okay, degrees over radians would mean how many degrees per how many radians. And if we remember that formula, or that equation, pi radians equals 180 degrees, we can make our ratio just like before, 180 degrees over pi radians. And then all we have to do is multiply across just to get our degrees, which is 540 over 4 degrees. By dividing by 4 over 4, we can simplify our answer to get 135 degrees. Example 2 is 210 degrees. But this time it's different. We have degrees, and we have to find and convert it to radians. We can do that by multiplying by radians over degrees, instead of previously multiplying it by degrees over radians. And we know that we have to multiply by radians over degrees because the degrees will cancel when we multiply it. If we remember that equation again, pi radians equals 180 degrees. We can use it to make our ratio, pi radians over 180 degrees, to help us solve and find our answer. So if we multiply across, we have 210 pi over 180 radians. And we can simplify it by dividing by 30 over 30 to get our final answer, 7 pi over 6 radians.